For today's demonstration, we'll assume we are the manufacturer of medieval trebuchets. We have multiple manufacturing locations, some of which build sub-assemblies that are used at other locations. Our goal is to have plant-specific bill of materials that correctly reflect whether it is a make or buy for that location. To do this, we will leverage PTC's MPMLink module and the new view-specific enterprise data capability. From the top-level assembly, we will open the Manufacturing Associative Part Structure browser. This tool allows us to view and manage the structure and associative relationships of parts or assemblies within the context of an upstream engineering BOM and its downstream manufacturing BOM. Engineering BOMs are typically oriented towards functional relationships, which may not be consistent with how the product is built. In this example, we want to include a phantom assembly to capture that the counterweight bucket sides are built as a subassembly at one location and transferred to another location for final assembly. We select the action to create a new downstream branch and select the option to duplicate without propagation. This option will create a manufacturing view of the object we specify and duplicate the structure underneath. We can also create the manufacturing view without any structure underneath it, or duplicate the structure while creating a manufacturing view for each of its child objects. Typically, a new manufacturing view is only created when it deviates in some way from the design view. With the manufacturing view of the counterweight now in place, we will create the new phantom subassembly underneath it. We can create the new subassembly from within the Manufacturing Part Structure browser from the Uses tab. We will assign the number and name to our new subassembly and adjust any other desired properties at this time. With the new subassembly created, we will assign a quantity of 2 and drag and drop the child objects onto it. Note that the quantities on the child objects are automatically adjusted to reflect the correct counts. We have now completed the addition of an extra subassembly that will be common to the plant-specific BOMs at all locations. Note that the window on the left of the Manufacturing Part Structure browser always reflects the upstream view, while the window on the right reflects the associated downstream view. Before creating our plant-specific BOMs, let's check in the changes we have made so far. To create the BOM for our Bristol plant, we will first change the downstream filters to display the Bristol plant. Display filters like this are typically created by an administrator and then can be applied by users. Users can also create new display filters or extend these save filters as needed on their own. The upstream window will now be changed to display the manufacturing view that is common to all plants. We can see the current display filters being applied in the header bar of each window. The new downstream branch for the Bristol location will be created without child objects since this location does not build the subassembly. This subassembly is built and transferred from the Derby location, so it is considered a plant buy at Bristol. We can now adjust any plant-specific properties. For example, we can specify where the inventory is normally stored within the plant. We will now adjust the make buy attribute to reflect that it is considered a plant buy at Bristol. Finally, we will go ahead and check in the changes we have made so far. The next step will be to create a plant-specific branch for our Derby plant that accurately reflects how it is built there. Again, we will begin by specifying the applicable display filter for our upstream and downstream windows. We will then create the Derby-specific downstream branch, but this time we will include the child structure since it is built at Derby. For each plant, we want to have a complete and accurate bill of materials reflecting its state at that location. Again, we can adjust any plant-specific properties. We will now specify where the inventory is normally stored at the Derby plant. The attributes that are available can be configured to meet your specific needs. We will now adjust the make by attribute to reflect that it is considered to be a plant make at Derby. We can even extend the bill of materials with any additional items required by the manufacturing process at Derby. For example, there is actually a shipping container that is used to facilitate the transfer to Bristol, so we will want to include that in our bill of materials as well. We can create the new shipping container from within the Manufacturing Part Structure browser by going to the Uses tab and specifying the name and number we want to assign to it. Additional attributes can be assigned as well. We will now go ahead and check in the changes we have made so far. We can review the engineering bill of materials as well as all the plant-specific bill of materials by simply changing the display filters from within the Manufacturing Part Structure browser. Note that the window on the right is currently showing a lower level subassembly. We'll adjust the display filters so that we can see the equivalent downstream part from our engineering BOM, and then we can go ahead and open it directly, and then view all of the different downstream views by simply changing the display filter. So we see that at Bristol we have a plant buy, while at Derby we have a plant make. We can go ahead and show our enterprise data. Note that the view-specific enterprise data is actually treated as a sub-object associated with the plant view of this subassembly. Next, we would like to add some configuration options to our trebuchet. In addition to the standard swing arm, we would like to add a long range and a heavy duty option as well. We will begin by adjusting our top level assembly to be a configurable module. We will also change it to be an end item. The end item designation implies that it's a saleable unit and it typically will have a SKU number assigned to it. We will make a similar change to the swing arm assembly and designate it as a configurable module as well. Next, we will add a new configurable assembly within the swing arm to replace the current swing arm. This configurable assembly will hold the 3 swing arm options in an overloaded fashion. We can continue our work from within the manufacturing part structure browser as well. Let's go ahead and open it at this time. First, we will drag and drop our standard arm to lie underneath the configurable module we just created to hold our arm selections. Next, we will want to create the 2 additional arms. We can do this by going to the Uses tab. We will then specify the name and number associated with each of the 2 new arms. With our 3 options in place, we will then go to the Details page for the configurable module we just created to hold the selections so that we can assign the option set that allows us to specify which arm option is being applied. You can see that I have already created a couple of option sets, so I just need to select the applicable one to be assigned. Options and choices can be created from the Option Pool tab of the product or library container. They can be segregated within groups in the tree structure to better organize them. Option sets are then created to define variations within a product family. Choices are added to the option set by referencing options from the option pool. When working with complex products, you may need to use different option sets for individual subsystems or technologies while using a top-level option set to control the overall product configuration. Going back to the configurable module I created for the arm selections, I will now enable the applicable choice for each of the arm options. An option set is a change managed object, and you can initiate a promotion request or change request against it to release it. I will now return to the top-level assembly and assign an option set to it so that I can control the arm selection from the top-level product. To view the corresponding assembly structure for each of the arm options, I can simply go to the Option Filters tab within the Display Filters and select the desired option. We will begin by selecting the Long Range option. We can see that the assembly structure is updated to reflect the correct bill of materials for that configuration. I'll now change the option to view the heavy payload option. Again, we see that the assembly structure is updated. When we are done, we can go back into the options filters and clear our choice. And once again, we will see that the overloaded structure is reflected in the bill of materials, showing all the available options. We'll go ahead and check in all the work we've done so far. Next, I would like to highlight how the product structure we've defined in Windchill can be shared with the rest of the organization using the Windchill ESI or ERP connector modules. Out-of-the-box distribution targets are available for SAP and Oracle, but can also be created using XML files and a variety of transports to provide a real-time connection between Windchill MPMLink and other systems. Supports the transfer and mapping of business objects such as parts, bills of material, configurable modules, change objects, documents in CAD, and even manufacturing objects. This is a highly configurable module, and implementation details will vary greatly depending on the needs of your organization. However, I will focus on a very simple example. I want to highlight the plant-specific information that we created earlier. Returning to the manufacturing parts structure browser, I will create a plant view of our top-level assembly for each of our plant locations. The plants may only need to receive information from the lower-level assemblies pertinent to them, or they may wish to receive an entire top-level bill of materials as seen from their particular perspective. If this is the case, we will want to create a plant view of the top-level assembly, which will then be inherited at all levels as it is published to the distribution target. Once I have completed creating each of our top-level plant-specific views, I will exit the manufacturing parts structure browser and select my first plant view. I first need to assign the corresponding distribution target to this plant view, and then I can manually publish to this distribution target. Although I am manually publishing for this demonstration, this would more typically be accomplished within a Windchill workflow during a change approval process to release the product. I will now change to my second plant-specific view and assign its distribution target and publish it as well. I have my distribution targets configured to create an XML file in a designated shared folder location on the network. So to view our results, I can simply browse to that location and open the XML files that were created. I will first open the XML file intended for our Bristol plant. I search on the bucket side assembly, and I can see that this assembly is designated as a plant by, and that its storage location at Bristol is within Building 2. I will then open the XML file intended for our Derby plant. I search on the same bucket side assembly, and I can see that this assembly is designated as a plant make, and that its storage location at Derby is on rack 37. This completes our demonstration.